Welcome back to Low Stress Math with Mrs. Bono. We are in Unit 1, Chapter 1, Lesson 9. The negative exponent. We've seen negative exponents, but what do they mean? Let's find out. So Lesson 9, the negative exponent. All right. Let's do the warm-up first and then go back and take a look at the target. So for this one, expanded form, 3 times 3 times 3 over 3 times 3 times 3. Simplified exponential form, let's see. Oh, that'd just be 1, which, by the way, same evaluated form. So for this one, 3 times 3 times 3 over 3 times 3 times 3 times 3. What's going on here? 1 times 1 times 1, 1/3, which is the evaluated form, 1/3. And now it gets interesting. Go. 3 times 3 times 3 over 3 times 3 times 3 times 3 times 3. 3 over 3, 1. 3 over 3, 1. 3 over 3, 1. 1 over, let's see, 3 times 3. 3 squared. 3 squared is 9. 1/9. Okay. What happens, though, if we do this? 3 minus 4. That'd be 3 to the negative first power. Okay. But if we do this one, 3 minus 5, that's -2. It's 3 to the negative second power. This is the real exponential form. But that's exponential also. And that's where we're going to get into today. These negative exponents. So target. Use the negative exponent to simplify expressions. I'll use the negative exponent rule. To simplify expressions. All right. So now let's simplify and then evaluate the following expression, the quotient rule. So I'm going to take, the quotient rule says keep the base and subtract the exponents. So top minus bottom, 6 minus 8. Well, I still have 7, and 6 minus 8 is -2. So the quotient rule says I should have 7 to the -2. But expanded form says 7 times 7 times 7 times 7 times 7 times 7 over 7 times 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 7. Let's double check, because you know me. 1, 2, 3, 4, 5, 6. All right, 7 is used as a factor 6 times on top. 1, 2, 3, 4, 5, 6, 7, 8. And 7 is used as a factor 8 times on bottom. 7 divided by 7 is 1. 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 So now I have 1 over 7 times 7, 7 squared. Let's take a look at that. Now I have 7 to the negative second power, and that is equal to 1 over 7 squared what happened? Well, this is equal to that, but it's also equal to 7 times 7, 1 over 49. All right, so this is simplified. This is simplified with a positive exponent, and this is evaluated. It's going to get more interesting. Let's keep learning. Ba, 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 ba. Next page. So, to simplify a negative exponent, make the expression a fraction. Okay. I think I can do that. X is not 0. There's a reason for that. You cannot have a 0 on the bottom of a fraction. We've talked about that in the first chapter. So, make the expression a fraction. In other words, x to the negative n is going to be over 1. And then you're going to flip it over. You're going to do the reciprocal of the base. In other words, flip it. And then make the exponent positive. Because once you flip it over, the exponent becomes positive. So let's do a couple of these problems until you're comfortable. First of all, let's make this expression into a fraction over 1. Because you can make anything over 1. And then you find the reciprocal. Well, the reciprocal of 5 over 1 is 1 over 5. But instead of having a negative exponent, now you have a positive exponent. So the same thing here. I'm going to put it over 1. I'm going to take the reciprocal, which is 1 over 4, and then you make the exponent positive in the denominator, 3. Okay, and it doesn't matter if you have a letter or if you have a number. So, oh, here's me not reading directions again. Write the expression using a positive exponent. So I did that part, but I did not evaluate. So now I got to go back and I do some evaluating. Let's see, 5 squared, 5 times 5. This, 1 over 25. 4 times 4 is 16, and times 4 again is 64. So 1 over 64. You know, if I grab my calculator for a minute here, and I go back and I put these negative exponents in, so 5, and then use that little up arrow looking key, the caret, -2. When I hit enter, look, it made it a fraction. See, you can always use a calculator to help you with this kind of problem. If you're not remembering everything, go back and try the calculator. 4, caret, -3, and look at that, 1 over 64. Okay, so this one, I'm going to put it over 1, and I get 1 over a, and now instead of -5, it's a to the positive 5th power. G willikers, I'm going to put it over 1, take the reciprocal, i.e. flip it over, and get 1 over g, and now instead of to the -7th power, it's g to the positive 7th power. So I cannot evaluate either one of those expressions because I don't know what the variables are equal to. So I'm just going to put a little box around it. Ha! Normally, I say what? Put it over 1. But this is already a fraction. So I have to just reciprocate it. just flip it over. So instead of having 2 over 3, I'm going to have 3 over 2. But don't lose the parentheses. It's to the negative power, but once I flip it over, that power is positive. And let's see. 3 times 3 is 9. 2 times 2 is 4. So I get 9 over 4. Let's see what it looks like if I put that in a calculator. Parentheses, and I get 2/3, 2 over 3, in parentheses. Now, up arrow, -2. See, I put it in as it looked originally, and I get up 9 over 4. Aha! Very clever. This one is going to flip over also, and I get 4 over 3 in parentheses, because the whole thing is the base. -3 becomes +3. All right, now let's put that one in the calculator to get the answer to. I'm going to go back to the original. I'm going to put the original in, because that's the one I really want to get the answer for. And then I'm going to put this one in so that you can see that the answers are the same, no matter which way you put it in. So I have in here 3/4 to the -3rd power. I end up with 64 over 27. So I know my answer is going to be 64 over 27. But now, just to check it, I'm going to put in the equation I made, 4/3 to the 3rd power. So parentheses, 4 over 3, the whole thing to the +3rd power. Because once I flip it over, my exponent becomes positive. That's the negative exponent rule. And when I hit enter, you see I get the same answer, 64 over 27. So 3 over 4 to the -3rd power is equal to 4 over 3 to the +3rd power. Nice to have a calculator to check me with these things. Now, the fun part. Look at this. This has a coefficient, a base, and an exponent. And remember, the coefficient, 5 times x to the -3rd power. So that means that the base is x to the -3rd power. So I'm going to make the base a fraction, just x to the -3rd power. I'm going to make this part a fraction. Now, only this part gets flipped over. Did anything happen to the 5? No. It's 5 times. I'm going to flip that over to get 1 over x to the 3rd power, 1 over x. And my negative exponent becomes a positive exponent. What else could I do here? Well, if I put this over 1, 5 times 1 is 5 over 1 times x to the 3rd, x to the 3rd. That's interesting. So only the part with the negative exponent gets reciprocated, and 5 over x to the 3rd. The same thing is going to happen here. This is really the coefficient 2 times m to the -4th, and that's the part that goes over 1. Just the base goes over 1. So now, see, I have to come back here, and I have to look at that and say, you know what? Technically speaking, it isn't the expression that I made into a fraction, is it? Nope, Bono, that is so wrong. It's really just the base is a fraction. So make the base a fraction. I hate it when I make mistakes. Here we go. So I'm going to make the base a fraction and then reciprocate that, flip it over, and ba-bam. So now my base is a fraction. And I get 2 times, well, once I flip over that base, I get 1 over m, and the negative fourth becomes a positive fourth. But I'm going to do the same thing. I'm going to put this 2 over 1, and I'm just going to multiply straight across. 2 times 1 is 2. 1 times m to the fourth, m to the fourth. So 2 over m to the fourth. Things to be careful about: parentheses and coefficients. Have a great day.